We're going to take a look at used Ford Mustangs. So what is the average price of a used Mustang? Well, we did a sample of 25 off the Auto Trader website, and we recorded the prices in thousands of dollars for each car. So here's our 25 Mustangs. Here's our dot plot at the top with an average price for an average of 15.98. So our best estimate for the average price of a Mustang is $15,980. Now notice it's only 15.98 here, but it's 15,980 down here because that is what our last screen said. It's recorded our data in thousands of dollars. So this is thousands. So basically we got to take this number, multiply it by 1,000. That's how we get this. But the question is, how accurate is that estimate? So we'll use our Bootstrap. So here's our original sample. We could do a Bootstrap. And it might look something like this. We get the mean of that from our Bootstrap. We do the mean of this Bootstrap right here. And basically we want to repeat that many, many, many times. For the most part, that can be done on StatKey, which we'll demonstrate in another video. Now, when we do that here, doing it many, many times, we have our standard error right here. We have our original sample right here. And what we have down here is Bootstrap sample for where our mouse is pointing at, this one right here. So what's our 95% confidence interval? Well, remember it's our statistic, which we get from our sample, plus 2 times our standard error. So here was our original mean from our sample, plus or minus 2 times our standard error. Remember, it was in thousands of dollars, so we had to take what it said on the last screen for our standard error times 1,000, and we get this for our 95% confidence interval. So we would say we are 95% confident that the average price of used Mustangs on Auto Trader is between $11,622 and $20,338. So let's go ahead and take a look at the mean commuter time for people that live in Atlanta. This data was collected back in 2004. So here's the original sample. You'll notice there's 2 people that commute 3 hours, 3 people that commute 2 hours, and then there's a few people that commute an hour and a half. But most people are back here and commute 45 minutes or less. This is 100 or 500 samples, or not 500 is our sample size. The average from our sample, hence X bar, is 29.1111 or 29.11 minutes. But where do you think the true mean for our population might be? Where do you think for all, not just our sample, but all people that live in Atlanta, what do you think their commute time is? Well, once again, we want to do that bootstrap thing. So here we have our original sample where the radius of each circle represents how long they traveled. So here is someone that had an extremely short commute. Here, this circle right here is someone that had a very long commute. So we make really many, many copies. So we shrink that down and then duplicate it, duplicate it, duplicate it. Or you could just do it with replacement, which we often do. So 95% confidence interval for the average commuters in Atlanta. So we could do that on stat key. We have our original sample up here. We have our mean right here. We have our sample size. In this case, it gives us our median and the standard deviation of that original one. Um, we do our bootstrap. We have the mean of the bootstrap samples. We have the standard deviation of the bootstrap distribution here, which once again tells us our standard error. And then these two pieces of information, our mean from our original sample and our standard deviation of the sample, or of the bootstrap distribution, gives us our 95% confidence interval. So we take our 29.11 from up here, plus or minus 2 times our standard deviation of our sampling distribution here, of our bootstrap distribution. So in other words, we get 27.3 minutes to 30.9 minutes. So one more problem here. What percent of Americans believe in global warming? So a survey was done, and we had some people that said yes, and obviously some people that said no. So is there solid evidence for global warming with what people believe? So we want to go ahead and give and interpret a confidence interval here. So we'll go ahead and do that with stat key. And I'll show some of this stuff with stat key in a separate video, so don't worry about that. So we got to enter in our original data, and then we're going to generate many, many samples so that it's going ahead and telling us the standard deviation of this bootstrap sampling distribution. So this is our statistic from our sample. This is what we get, which is our standard error. And then we can do our 95% confidence interval, which is our statistic from our sample plus or minus our standard error. So we would say we're 95% sure that the true percent of all Americans that believe there is solid evidence for global warming is between 57% and 61%. Does it make a difference if it's you're a Democrat or a Republican? Well, in this case, we could go ahead and do a difference in proportions. And we could do a 95% confidence interval for that. So let's consider that situation. We would go to stat key. We would go to the middle column, which is confidence intervals, and we'd go down to difference in proportions. So you'd have to enter your data for your first one, enter your data for your second one, and it said to assume that there was 1,000 for your n because we did not know the sample size. This 790 comes from taking 79% of 1,000, or 0.79 times 1,000. Same idea down here. The 380 comes from taking 38%, which is 0.38 times 1,000. And then generating those bootstrap samples. And then it figures out our bootstrap distribution, or standard error, the standard deviation of our sampling distribution. So we need to take our statistic from our proportions, and we're looking at the difference in proportion. So you got to take the top proportion minus the bottom proportion. That's where the 0.41 comes from. And we have our standard error. So we take our statistic of 0.41 plus or minus 2, because we were looking at 95%, times our standard error. So we would say we're 95% sure that the difference in proportions of the Democrats and Republicans who believe in global warming is between 0.37 and 0.45. So is there a difference between the two parties? We would have to say yes. If your confidence interval that you got included 0, went on both sides of 0, you would say no. But since it does not go on both sides of 0, we would say yes, there is a difference. So here's just a quick overview of what we were just dealing with. And remember to do a 95% confidence interval. It's your statistic plus or minus 2 times your standard error, which we get from our bootstrap distribution, and it's the standard deviation of that.